Hey there, curious minds. Here's a mind-blowing question for you. What if I told you there's a living structure so massive you can actually see it from space? And get this, it's built entirely by tiny animals smaller than your fingernail. Sounds crazy, right? Well, stick around because by the end of today's episode, you'll know exactly what I'm talking about. And trust me, it's going to blow your mind. Hey everyone, I'm Ben, and welcome back to English Story Mode, the podcast where we dive deep into the most fascinating topics on our planet while helping you master English along the way. Now, if you're new here, here's what we're all about. Learning English doesn't have to be boring textbook stuff, right? Instead, we explore incredible science, nature, biology, and technology, all the mind-blowing facts that make you go wow, while naturally improving your English skills. It's like having the best of both worlds. You're feeding your curiosity and becoming more fluent. Pretty awesome deal, don't you think? Today, we are taking a virtual dive to one of the most spectacular places on Earth, the Great Barrier Reef in Australia. And let me tell you, this place is absolutely incredible. We're talking about an underwater wonderland that's home to some of the most colorful and diverse life forms you've ever seen. But here's the thing. This natural marvel is facing some serious challenges, and the story behind it is both fascinating and important. So grab your virtual snorkel because we're going deep. All right, let's start with the basics. What exactly is the Great Barrier Reef? Picture this. Imagine a structure that stretches for over 2,300 kilometers. That's about 1,400 miles along the coast of Queensland, Australia. To put that in perspective, that's like driving from New York to Miami. It's officially the world's largest coral reef system. And get this, it's so big that astronauts can see it from the International Space Station. Now that's what I call making a statement. But here's where it gets really cool. This massive underwater city isn't built by humans with concrete and steel. Nope. It's built by some of the tiniest architects on our planet. We're talking about corals. And here's something that might surprise you. Corals aren't plants. I know. They look like colorful underwater plants or maybe weird rocks, but they're actually animals. Mind-blowing, right? Each coral is made up of thousands of tiny animals called polyps. Think of them like little sea anemones, each about the size of a pinhead. But get this. These tiny polyps are incredibly diverse. There are over 400 different species of hard corals in the Great Barrier Reef alone. That's like having 400 different types of architects, each with their own unique building style. Some create branching structures that look like underwater trees, others form massive dome-shaped colonies, and some create delicate lace-like patterns. And speaking of diversity, the Great Barrier Reef isn't just about corals. It's like an underwater metropolis bustling with life. We're talking about over 1,500 species of fish swimming around these coral neighborhoods. Picture this. There are tiny neon-colored fish called parrotfish that literally eat coral and poop out sand. They're like nature's recycling crew. Then you have the gentle giants like whale sharks, which can grow up to 12 meters long but only eat tiny plankton. There are sea turtles that have been making this reef their home for over 100 million years. Imagine that. They were around when dinosaurs ruled the land. The reef is also home to thousands of species of mollusks, sea stars, sea cucumbers, and crustaceans. There are even species that scientists are still discovering. In fact, researchers estimate that new species are found in the Great Barrier Reef every few weeks. It's like finding new neighbors in your apartment building that you never knew existed. Now, here's where these little guys become the ultimate builders. Each polyp has this amazing ability to extract calcium from seawater and use it to build a hard skeleton around itself. It's like they're wearing tiny suits of armor made of calcium carbonate, the same stuff that makes up limestone and marble. Over time, millions of these polyps live together in colonies, and when they die, their skeletons remain. New polyps build on top of the old ones, and slowly, over thousands and thousands of years, these layers create the massive reef structures we see today. It's like nature's version of a skyscraper construction project. But wait, there's more. Here's where the story gets even more fascinating. You know those brilliant colors, the vibrant yellows, stunning purples, electric blues, and bright pinks that make coral reefs look like underwater rainbows? Well, those colors don't actually come from the coral animals themselves. Plot twist, they come from tiny algae called zooxanthellae that live inside the coral tissue. And this, my friends, is one of nature's most incredible partnerships. Picture this. It's like having the perfect roommate situation. The algae get a safe place to live inside the coral, protection from predators, a stable environment, and access to nutrients that the coral provides. In return, these algae are like tiny solar panels. They use sunlight to make food through photosynthesis. You know, that process where plants turn sunlight into energy? Well, these algae are so generous that they give up to 90% of the food they make to their coral hosts. Talk about a great deal, right? The coral gets most of its energy from these tiny tenants. And in return, the algae get the 5-star accommodation package. This partnership is so important that without these algae, most corals simply can't survive. It's like trying to run a city without electricity. Theoretically possible, but extremely difficult. And here's the kicker. This beautiful relationship that's been working perfectly for millions of years is now facing a serious threat. And that threat has a name that you might have heard in the news: coral bleaching. So what exactly is coral bleaching? Well, imagine if your perfect roommate suddenly became really stressed and decided to pack up and leave. That's essentially what happens during coral bleaching. When corals experience stress, and we'll talk about what causes this stress in a minute, they literally kick out their algae tenants. Without the colorful algae, the coral tissue becomes transparent, and you can see the white calcium carbonate skeleton underneath. That's why we call it bleaching. The coral looks like it's been bleached white, like a white t-shirt after too much laundry detergent. Now, here's the thing about bleaching. It's not immediately a death sentence. Think of it more like a coral having a really bad day and making a rash decision. If the stress goes away quickly, the algae can move back in and everything goes back to normal. The coral recovers its color and continues living happily. But if the stress continues for too long, well, that's when things get serious. Without their algae partners providing food, the corals basically starve. They become weak, more susceptible to disease, and eventually, many of them die. It's heartbreaking, really. So what's causing all this stress? Well, the biggest culprit, and this might not surprise you, is rising ocean temperatures due to climate change. Corals are incredibly sensitive to temperature changes. We're talking about just 1 to 2 degrees Celsius above normal being enough to trigger bleaching. It's like they have the world's most sensitive thermostat. When ocean temperatures rise, it's like turning up the heat in that perfect roommate situation we talked about. The algae start producing toxic compounds instead of food, so the coral says, hey, you're not helping anymore, you need to leave. And these aren't just gradual temperature increases we're talking about. Scientists have identified what they call marine heat waves, periods when ocean temperatures spike way above normal for weeks or even months. Imagine if your city suddenly experienced summer temperatures in the middle of winter, and that lasted for several months. That's essentially what these marine heat waves do to coral reefs. The poor corals just can't cope with such extreme conditions. But temperature isn't the only problem. There are other stressors too. Pollution from agricultural runoff can create water conditions that are toxic to corals. Too many nutrients in the water, which sounds like a good thing, right, can actually cause harmful algae blooms that block sunlight from reaching the corals. And then there are natural predators like the crown-of-thorns starfish, which can literally eat entire coral colonies. These spiky creatures are like underwater zombies. They move slowly across the reef, consuming everything in their path. Now let's talk about some recent events that really show how serious this situation has become. The Great Barrier Reef has experienced multiple mass bleaching events in recent years. And when I say mass, I mean huge portions of the reef turning white simultaneously. We're talking about 2016, 2017, 2020, 2022, 2024, and most recently, 2025. That's 6 major bleaching events in less than a decade. To put this in perspective, before the 1980s, mass bleaching events were extremely rare.
Scientists didn't even have a term for it because it hardly ever happened. The 2025 bleaching event was particularly concerning because it marked the sixth mass bleaching since 2016. That's an average of more than one major bleaching event every 2 years. Historically, coral reefs need at least 10 to 15 years between major bleaching events to fully recover. It's like asking someone to run a marathon, giving them only a week to rest, and then asking them to run another marathon. The corals just don't have enough time to bounce back before the next stressful event hits. But here's where I want to shift gears a bit, because this isn't just a doom and gloom story. There are people working incredibly hard to protect and restore the Great Barrier Reef, and some of the solutions are pretty amazing. Australia has established the Great Barrier Reef Marine Park Authority, which is like having a dedicated team of reef superheroes. They work to limit activities that could harm the reef, control outbreaks of crown-of-thorns starfish, and monitor the overall health of the ecosystem. Scientists are also doing some pretty cool research. They're studying corals that seem to be more heat-tolerant than others, basically the tough guys of the coral world who can handle higher temperatures. The idea is to understand what makes these corals special and potentially help other coral populations develop similar resilience. There are even projects where scientists are breeding corals in laboratories and then replanting them on damaged reefs. It's like coral gardening, but underwater. One particularly fascinating technique is called assisted gene flow. Scientists are taking corals from naturally warmer parts of the reef and carefully introducing their offspring to cooler areas. It's like helping evolution along, giving corals a head start in developing heat resistance. There's also something called coral probiotics. Scientists are developing beneficial bacteria that can help corals resist bleaching and disease. And here's something that sounds like science fiction. Researchers are using 3D printing to create artificial reef structures. These printed substrates give baby corals a perfect place to attach and grow. Local conservation efforts are making a difference too, improving water quality by reducing pollution and agricultural runoff gives corals a better chance to resist bleaching. It's like making sure someone gets proper nutrition and rest before they face a big challenge. It doesn't prevent the challenge, but it helps them cope better. And of course, the big picture solution involves all of us, reducing greenhouse gas emissions to slow down global warming and prevent those marine heat waves from becoming even more frequent and severe. All right, let's wrap up what we've learned today because, wow, we covered a lot of ground, or should I say, a lot of ocean floor. First, the Great Barrier Reef is absolutely massive, the world's largest coral reef system that you can literally see from space. Second, corals aren't plants or rocks, they're actually animals, tiny polyps that build calcium carbonate skeletons and create these incredible underwater cities over thousands of years. Third, those beautiful colors come from amazing partnership with algae called zooxanthellae. It's like the perfect roommate situation, where the algae make food using sunlight and share most of it with the coral, while the coral provides protection and nutrients. Fourth, coral bleaching happens when stressed corals kick out their algae partners, turning white and potentially dying if the stress continues too long. Fifth, the main cause is rising ocean temperatures and marine heat waves from climate change, though pollution and predators like crown-of-thorns starfish also play a role. Sixth, we've seen an alarming increase in mass bleaching events, 6 major ones since 2016 alone. And finally, there's hope through conservation efforts, scientific research into heat-resistant corals, improving water quality, and global action on climate change. You know what I love about topics like this? They show us just how incredible and interconnected our natural world is. A tiny algae living inside an animal that built underwater cities visible from space. I mean, come on, that's better than any science fiction movie. And here's the thing about learning English through stories like this. You're not just memorizing vocabulary lists or grammar rules. You're actually engaging with ideas that matter, expanding your knowledge about our planet, and naturally absorbing the language in context. That's powerful learning right there. And remember, Every time you listen to an episode like this, you're building your English skills bit by bit. Maybe today you learned new words like polyps or symbiosis. Maybe you got more comfortable with scientific explanations. Or maybe you just enjoyed hearing English used to explore something fascinating. Whatever it was, that's progress, and you should be proud of yourself. You've got this. Every episode is a step forward on your English learning journey. All right, before we dive into the deep end of the comments section, here's what I need from you. If you enjoyed today's underwater adventure, hit that subscribe button so you never miss an episode. Trust me, we've got some amazing topics coming up. Give us a like if this episode taught you something new. And here's the big one. Drop a comment below and tell us why you want to improve your English. Is it for travel, career goals, just pure curiosity about the world? I love hearing your stories. And here are some questions to get you thinking. What's the hardest part of learning English for you? Is it pronunciation, grammar, or maybe just building confidence to speak? And which topic should we explore next? Maybe the mystery of how birds navigate during migration? Or how about the science behind why music gives us chills? Let me know. Plus, don't forget to check out the description box below. I've put together 10 questions about today's Great Barrier Reef topic to help you practice and reinforce what we've learned. Until next time, keep exploring, keep learning, and remember, the world is full of amazing stories just waiting to be discovered.